All right. Well, thank you, everybody. I hope that you had a good break. Took a look at the photos. Seems to have turned out very well. So thank you very much. We'll get that up on the. I guess I should meet our GDPR requirements. I hope you're all okay with your private photo post. Well then. I guess I should probably wait for it to start again.
Now we're going.
Okay, thank goodness. After that discussion. I'd very much like to welcome up Mathias, is it Bavay? Bavay, to speak with us about data access made easy, flexible, on-the-fly standardization and processing. So thank you very much, Michael.
Yeah, thank you. So hello. Maybe just to mention, I work for the W.S.L. Institute for Snow and Avalanche Research in Davos, Switzerland, and alongside with my colleagues here. We had several projects in the fields of data access. That's why we decided to group everything under the umbrella data access made easy. It makes a nice acronym. And here I want to show you how we try to do flexible on-the-fly data standardization and processing.
The battery's a little bit flaky.
Okay, but I will do without. You might wonder if why do we need to do something for data standardization? And if you look at this map, for example, here you see on the left, this is a map of stations, automatic weather stations affiliated with the WMO. On the right, this is just in Switzerland, the network measuring network that we have for avalanche warning. And actually, if you look at these monitoring networks, everything works fine. There's no need for anything special. It just works. But if you look at research automatic weather stations, these are really stations that have been installed to answer a specific scientific question. And they are not standardized. And they're not standardized like monitoring networks. And you can see with these pictures, they are all research automatic weather stations. They are all totally different. And this is a huge diversity, which is really the biggest challenge. It might be diverse in terms of measured parameters, sampling rates. It might be from very small number of sensors to a huge number of station per station. So it's really big variability. The sources of the data, once you pull the data out of the data logger, out of a station where this is stored and hosted, it might be in databases, in web service files, whatever. Diversity in data formats. I've seen many wild variants of CSV files, and it can be also binary files, it can be anything. And any of this, the whole station setup can change at any time, any number of times during the station lifetime. Worst case, I have some stations like several times a week, a full change of a station. And I want to give you an example. In Davos, we have lots of weather stations all around, and one is in Stillberg. That's been automatic weather station since 1975. And this station obviously had experienced lots of changes in terms of types of sensors, number of sensors, sampling rates, and so forth over the years. It has been fully rebuilt several times. And also it even changed ownership. It got transferred to our institute in 2005. It was a different owner before. And I don't want to be disrespectful to anybody, but I think that nobody really looked into the old data because I found lots of surprises. I want to show you here an example. It's an extract of data file from 1976. You can see you have like 4 lines of header. I've truncated the headers because overall you have 106 fields, so it's a little long and boring to look at. Afterwards, you have some data lines. We start with the year, coded onto digits. You have month there, you have the hour, and then you have some measurement values. You have a second line of a header. This is like a sensor name. And then you have the units, and you have something. It turns out it was not documented anywhere, but afterwards I realized actually the last line of a header, this is a factor that you have to apply to the measurement in order to fall back on the measurement units. Something that was not said in the headers and not said anywhere, as I realized after a few months actually that it was the case, is that you have sensors from multiple stations written into the same file. That's why you have 106 sensors or columns, It's not that you have all of these on the same station. It's multiple stations just aggregating all the stuff on the same into the same. And just with the names, you're somehow supposed to figure which one goes to which station. We don't even have the coordinates of the station, by the way. So on top of that, you have changes of a number of sensors within one file. So the headers don't match anymore. And we had also some fields that got swapped over time and swapped again. More, I wouldn't say randomly, something happened, but it was not documented anywhere. If we fast forward in time, we take a file here from year 2000, it's slightly different. You see now the year is over 4 digits. We still have multiple stations into one file, but this time with a station number or station index at the start of each data line. So this is this kind of stuff that we want to deal with. And our ultimate goal is that we want to have automatic weather stations for research applications that are somehow going to be transformed with some kind of magic to make it fair. And on top of it, we want to make it cheesy. So now that this is set, well, our first requirement, it's data standardization. The goal is to be able to handle the various input formats. It can be totally wide. We need to be able to read no matter what it is, and then to write everything out into the same output format. Like in my pictures here, you go from raw R into a standardized product where you know it's always the same no matter where it's coming from. We want to have the same parameter naming, so it's easy to retrieve your parameters. You don't have to know that one was written in Bulgarian, the other one in Japanese, the other one in whatever, or with abbreviation in one way or another one. And we want the same metadata for standard. And for us, it will include SCDD search metadata. The second requirement is reproducibility. We want to be able to track the history of the changes, and we don't want any manual editing of the data. If we do manual intervention into the data, it's not going to be reproducible anymore. I've tried multiple times just to write down everything I do on my data file, and then to try it again following my notes. I never come back to the same file as what I had on first time, although I'm sure I documented everything perfectly. So no manual editing, everything will be generated on the fly. And it needs to work for any period of a station's lifetime. So now I want to show you our new system. Øystein said that it would be up and running fall 2023. This is fall 2023. So let's have a look from the point of view of the user experience. Can go to our web service homepage. Currently, it's only a test server. You log in with your, you come to this page. You log in with your ORCID ID. Just before you start just uploading gigabytes of data onto that thing, it's a test server. We don't have lots of room. It will be in a few weeks on a permanent server. And then you come to this page. And here you go into guest job submission. You come here to this form where you can upload your data here, upload there. You provide the start date and the end date. You click on launch job. And here it is. You have standardized this netcdf CF with SCDD metadata. If you look into this netcdf file here, you see that this is CF on the left part of the header. On the right part of the header, you have your SCDD metadata. So now it's magic, right? Except that you know when there is magic, usually there's a trick. And you're right, there's a trick. I will be even doing something I should not do, but I will tell you what is the trick. And the trick is on this form here, I was a little mischievous because behind this upload here, there's something hidden. There's another file. It's not only your data file. And this something, if you look into this system, is that here I just add a configuration file. The whole processing that needs to happen to the file to make it standardized is described into a configuration file. It describes everything per station valid for the whole life of a station. And the processing is actually provided by our meteorological data pre-processing library. It's something we started in 2008. We use it for Avalanche running applications in operational use. And this is open source. And if we look into what Meteorological does, you have this fixed processing steps that are going in serially, one after the other one. You choose first, when reading the data, different input formats to choose from. When writing out the data, you will also choose different output formats that you want to write the data in. You have in between, like what I call raw data editing. This is editing operations. It will be, for example, you need to swap two sensors, or you want to merge two stations together, or you want to split a station into two substations, that kind of stuff. You have also lots of filtering. So in the filter step, you can choose between different filters that will apply corrections on your data, or that will kick out some points, bad points in your data. Nothing is hard-coded. Everything is described from this configuration file. It doesn't do anything behind your back. It's really following and playing basically what you have into this configuration file. And the goal is that this file should be something that is understandable by the human in, let's say, 50 years from now. So that I won't believe for any moment that my system will still be up and running in 50 years. The people should be able to take the raw data, the configuration file, and to redo with their own system or manually to recreate the same files, the same output files. I want to show you now an example of such configuration file. This is in any format for what it means. You can see here, this is structured in sections. Here we provide like geographic metadata, very basic geographic metadata. So here we inject what is the station coordinate, the station name, station ID, that kind of stuff. We define what is reading, what kind of plugin we want to read the data, so to have a format, to parse the format, what is the location where you can find the data. We describe here the file structure. So it will be what kind of delimiters you have, what kind of columns you have, and so forth. We'll have a list of files that are going to be read and processed as raw data files. We can also have a whole reading, and so it can be also per file. We can also override some of these keys to say, well, this file is different, so it has different fields, and just for this file. You can apply some corrections like I do here. I do a correction on the timestamps, for example, just to remove duplicates, because it happens that we have duplicates into the files. And finally, you define the output format here in that CDF, and you also inject some metadata, for example, data creator and so forth. So of course, writing the ini files is key. The ini files are really the key to the system. This is what gives you the whole information, whole knowledge on how to handle this raw data file and how to process it. In order to support you when doing it, we have extensive online documentation, very detailed on all the possible tools that you have in this toolbox. And we have also a graphical user interface that is dynamically generated. So in the sense, as soon as we put a new key somewhere into the system, it's very quick to have a new key also coming into the interface here. And in the interface, you have also direct links to the matching page on the documentation. And you can actually have a paper and GND that describe this interface. We show also, we can have a preview of the raw data files into the interface, where we try to do this kind of syntax highlighting to help you to guess what should be the structure of this file. So now I want to look as kind of overview of a system, global cryosphere watch use case. So the whole system is mostly automated and decentralized. First, the research centers are going to provide raw data and metadata. On totally the other side, the users are going to get the netCDF files with CF and SCDD metadata, so this is fair data. These files are going to be served through a web portal. The web portal is actually not storing the data, but requesting the data through OpenDAP, and also populating a metadata database through OpenDAP and threads. And finally, in between, you have Meteor doing the whole processing to standardize, to use this ini file that's been given to standardize the data. Now, another overview of the system here. So this is what we have: data acquisition, data refining, data publication. The data acquisition part is out of scope. We don't do it. We consider as whichever system that gets the data out of the station, put it somewhere. The whole data portal and so this is what Øystein already presented. So I'm not going to talk anymore about it. And then what we have here in between, so Meteor doing the processing. We have initial to create the ini file to submit to a web service, and the web service is just going to run Meteor on it and create a standardized file. What we see here, actually, we have a hint of it, so there's really a role for a data owner here, for somebody who takes ownership of a station. And this data owner is going to write the ini files, react to errors or warnings that are reported by Meteorological, which might be that the raw data file format has changed in the meantime, for example, and define filters and quality level. And to support the data owner, we have a view where you can see the list of data sets you're in charge of. And for each data set, you can configure here. So provide what is your raw data, what is your ini file to use. You can automate with SFTP to upload the data with cron jobs that you configure here for running automatically. When you have a data set that is public, like the last one here, anonymous users will be able to see them and to request the data. And so because you can automate the system, you can deliver up-to-date data set. You can say it runs, for example, once a day for the last 1 month or something. And the users can also connect and say, well, you have your ini file that describes the whole life of a station, so I can request the last 10 years of the data. On demand, it will just process it and return the last 10 years of data. In terms of upcoming developments, here, currently, so this is the whole system, the whole thing as we see it for the longer term. We have currently 2 projects that are funding the development of a web service and 1 project funding work on Meteorological. For web service, it will be formally released as open source in the next few weeks. What we want to develop is data visualization. That's why I was kind of asking questions yesterday. It's okay, when we have big data sets, we have some data sets like 50 years long almost. How do we have a nice online visualization into this system that people can have a preview of the data? Also to have monitoring views and automatic alerts, because we can do also, if you define these filters, you can have a report that tells you which points have been excluded for which station at which time for which reason. So if you just aggregate all of this information, you can have a nice information about which sensor on which station is starting to make problems. If suddenly you see a relative humidity sensor is starting to trigger lots of filters, it's most probably that it's failing and it's time to give it a visit. So we want to have these views. I tried here to imagine here something that could be per sensor and to see a timeline of a number of errors of filters that have triggered. That could give a good hint. Is it a data transmission problem? Is it a data logger problem of batteries? Or is it really that the sensor is starting to fail? And we want to have also automatic alerts based on the same thing. That as a data owner, you could say, if I have more than that many errors or filters triggered on a specific sensor, I want to receive an alert. I want to know it, and then I will go look into my data and maybe send a technician to have a visit on the station. And what we would like to have also is publication with DOI reservation, that it would say, well, my data is in good shape. I added more and more filters to have a specific quality level. I'm ready to publish. I pre-reserve a DOI, so the DOI can be integrated into the metadata in the data file, and then I can finish the publication process to have a fixed data set. And for future projects, what we're looking for, we're hoping in the next 2 months to have a proposal on metadata collection and editing, where the goal would be to have some mostly automated metadata collection on the field. You know, with your cell phone, you know where you are, you know when it is. You could scan a few sensors and so with a QR code, and then with very few information on top of it, it will be already big step forward for us to know what happened on the station, and to have also a system we could just online afterwards in the office, just come and add maybe some more metadata. And here I'm really interested if some of you have more experience, more ideas, and so I want to work together with us that we could talk on this topic. So I'm done. If you want to know more, you can have a Meteorological paper in GMD 2014, initial paper GMD 2022, and we'll have some kind of overview of the system in the Data Science Journal in 2020. Thank you.
Fantastic. We have some time for questions. So any questions for Michael? Oh, sorry, Matthias. Oh, terrible. Questions? I know that Antos have some weather stations that they're looking to put out as well. So I'll just say for my part, I think I'll probably be pointing them to this kind of information. I think that they would certainly see the diversity cropping up. Yes, Frank.
Yeah, I'm not sure if you mentioned it or just missed it, but so is it designed that for like a 50-year weather station, like all the data will be one file and then your ini file would be updated for different time periods, or the data would be like, you know, each year has a file and then gets its own ini file?
For the input data, it can be anything. This Stillberg station basically had worst case more than 100 input files per year. And then I had some years where suddenly for multiple years I have just one file, so it can be anything. The ini file, you can define your filters, your editing operation, and so per time period. So you can say from this time to this time, I need to control these two sensors because there's an error here. From this time to this time, I want to kick out whichever sensors because I know they're not working. From this time to this time, I need to apply this kind of correction on the, for example, removing an offset on the sensor. And then at a different time period, it's a different offset. And this is really some, in the end, it makes quite a long ini file, but then you really have a full description here for this station, this Stillberg station I have basically, so since 1975, one file that describes everything that happened on the station, with lots and lots of changes, periods that have been kicked out, filters that are kicked in and next week, some points, offset corrections and so forth. Time problems with the timestamp that you correct the timestamp that was like move forward by half an hour for a specific period of time, so we bring it back half an hour and so forth.
Yeah, I can certainly see how it'll be powerful, and I like the explicit nature, and especially that there's a formal way of describing the data.
And I think for me, it's really the value as I see it. See, you can scrap the whole software, but 50 years from now, somebody could say, I read this ini file and I know what to do on the data in order to reproduce again final data products.
Well, thank you very much.